CIRCE is one of the largest facilities that we have in Brasimone, and today we will visit it. And it's worth to mention that CIRCE has been constructed in 2000 to develop technologies for heavy liquid metal pool for nuclear application. It has an inventory of 90 tons of LB, and so far is still the largest facility in Europe and in Italy to develop this kind of technology. Here we are on the upper floor of CIRCE, and now we are going to have a look on how CIRCE is working. CIRCE is, as I told you, is a pool type facility filled by 90 tons of LB. We use LB because when we started with this experiment, LB was used to reduce the freezing temperature, but it's worth to mention that it's poor applicable for LFR. Now in the present configuration we have a pump, mechanical pump. This is the first pump ever tested in a so large pool. We have a helical coil steam generator, and we have a height source of 1 megawatt. So CIRCE is a facility with 1 megawatt, and we are able to simulate the full operation of the LFR primary system. Here we are moving in the lower plenum of CIRCE. CIRCE is a facility of 10 meter height, and here we are in the middle plane while we are moving in the lower part. In the lower part we have the capability to transfer the lead during the fill and drain of the facility. Here we have the lower part. This is the main vessel with the support of the main vessel. This is the transfer tank with the valves, and in the upper part we have the storage vessel. This system has been conceived to work with a safety approach, so we don't have a pump here, and we move the lead using the valve, using the transfer tank as a piston, while without pressurizing the storage and the main vessel. The only vessel is pressurized is the transfer tank. Now we move on the upper part, in the middle part, in which we'll have the reactor vessel cooling system that we use for our experiment. Here we are in the medium plane of CIRCE. This system is the piping for the cooling of the reactor vessel. We simulate a reactor vessel cooling air system in which we inject air in a gap between the main vessel and the thermal insulation. And this system is used for our experiment because here we will study the natural circulation induced by the air wax in contraposition of the natural circulation induced of a deep cooler immersed in the pool. And the goal is to demonstrate that our numerical tools are capable to catch the phenomena. It's worth to be mentioned also that here we have the storage tank of CIRCE. The lead bismuth stay in the storage tank during the maintenance and the refurbishment. In this moment the lead is there and it's kept liquid at 150 degrees C before to fill in the facility and before to start the experiment. Here we are on the top head of CIRCE. This is the cover. CIRCE is a facility with the 1.2 meter in diameter, and here we can see the main component of the pool. So in front of us we have the core simulator with the yellow cables, because the core simulator is fed by electricity, direct current to increase the reliability, and we have a 1 megawatt of power installed there. And the pins are 37 arranged in hexagonal lattice. On the right of the core simulator, we have the steam generator. This is the vapor chamber with the outline of the steam, with the steam, so the steam line. And on the back we have the pump. The pump is a vertical pump, axial flow mixed pump with a flow rate of 100 kilograms per second and a temperature of 450 degrees C during normal operation and a pressure head of 1.5 bar. As I told you before, this is a unique prototype being to be tested in a pulk type configuration. And finally there, we have the instrumentation. We have more than 100 thermocouple in the pool to monitoring the mixing and the stratification. Here we have the storage tank. We have already discussed it, but the storage tank is one of the most important components allowing us the refurbishment of the facility. And here we have a part of the oxygen control system. This is very important because in CIRCE we tested for the first time in a so large system the capability to control the oxygen content into the melt, and we have demonstrated that we are able to manage the oxygen content in the range of 10⁻⁶, 10⁻⁸ weight percent, so fully online with the requirement of our reactor. Here we are back on the top part of the CIRCE, and here we mainly have the secondary system. This is the feed water system, so we are able to provide 180 bar feed water at 350 degrees C, and this is the water that we supply to the steam generator. That's our helical coil steam generator. That is a prototype that we are going to test here with a power of 450 kilowatt. This is the feed water line, the isolation valve, the steam line with the steam valve, and the system to discharge the steam outside the building. And here you can have you can have a look on the top of the CIRCE, and you can see the component that I have already described. It's worth to mention that from the top we see also the bubble tubes. That is a system that we use to control the pressure into the melt and to control the oxygen content into the pool during a normal operation. So, thank you for coming and visiting us to visit CIRCE. CIRCE, as I told you, is one of the best facilities that we have. For sure, one of the most important facilities in Europe to develop LFR technology. And today we are continuing and working on it to develop the program on LFR. Enjoy the video and enjoy your time. Bye-bye.